And present, this is sort of a hybrid meeting with electronics and all the frustrations that go along with electronics. This is the Board of Public Works meeting, Monday, May 20th, 2024. We're running a little late because of technical issues. Tonight's agenda, we have two items for discussion. The long-awaited proposed 40B project, vital crossing development off of Ferry Street. We have the consultant tonight, Environmental Partners, that will make a presentation of the aquifer and all those issues that they found to deal with the aquifer. What I would like people to do is hold your questions until after the presentation. John, did you have a chance to get any cards?
We didn't have any cards, but I left a notebook for you.
Okay, so we have
table with a pen, write your name, your address, and your question.
So if we we'd like to make it the presentation to go forward, then we'll ask the board members for if they have any questions. Town council has any questions, and then we'll turn it over to the floor. Any questions? So as Sean said, there's a piece of paper. If you have any questions, write them down. Then we'll take the questions back. Those people at home, I think there's a chat issue on the Zoom that you can chat, and so we'll look at those too. With that, I want to turn the floor over. I'm going to start the meeting. Tonight's agenda is the 40B project, and then Wilson Road right-of-way discussion on the right-of-way. So that's the agenda. We're going to have a superintendent's report.
I have just one thing to give you guys.
One thing.
Yeah.
And our next meeting is on June 3rd. That is the agenda for tonight's meeting. Does I have a second on accepting the agenda?
Second.
All in favor? Aye. With that, this is an engineering study which the engineering department has taken the lead. So I'm going to ask Rod Procasino to take over the floor.
Sorry about that. Yeah. Good evening. So this will be the first time I think the board has seen any results from this study tonight. We have Environmental Partners, project manager, Anne Marie Tuberville, Kate Russa, who's the environmental engineer, and Mark Kaufman, who's online, is a hydrogeologist specialist in the modeling from McLean. They're the sub-consultants for Environmental Partners. They've, and Anne Marie will discuss what they covered, but I'll just briefly, we're talking about the denitrification system. They did a review. It's been reviewed by several engineers at this point, but they've done a review of it, and we received the data that we had asked for. We just recently got the data. It wasn't in its purest form, but it was enough to satisfy their requirements. So the other thing was that they've reviewed all of our Zone 2 studies and reports that we have since the Zone 2s were developed for the Little Creek Aquifer. We had some discussion about raised landfill and potential impacts there, and there might be some discussion on that. And then we had a desktop modeling performed to look at the travel time for both the nitrates and the PFAS. And the PFAS is a major issue at this time, although not regulated, with regard to wastewater, but it is a major issue to our drinking water supply wells. And then I guess if we have time, we might discuss the types of conditions of approval that the board might want to consider. So with that, I'm going to leave it to Kate, or?
Yeah, I'll take over.
Okay.
Yeah, so I'm Anne Marie Tuberville with Environmental Partners Group, and I've been with Environmental Partners since '98. And like Rod said, I'm working with Kate Rusa, who is a project manager in the wastewater group and is incredibly knowledgeable about the wastewater regs and water discharge permits and Title V. And so she's going to give a presentation on that aspect of the study. And then worked with Mark Kaufman at McLean Environmental. We've been working with them since 2000, so we have a large history, especially working in southeast Massachusetts on from simple to very complex groundwater models. So he's very familiar with this area and the hydrogeology. So next slide.
For those on Zoom, are you seeing the full screen slide or are you seeing the presenter view?
We are seeing the presenter view.
Okay, that's what I thought. Let me check, let me switch that for us. Is it all right if I drive to switch the right screen?
Do whatever you have to do.
Okay. Bear with me. How's that?
Yeah, we still got the guys in the corner, but that's all right.
Full screen. We're good.
Yeah, I think because Mark's talking.
All right.
All right, so our goal tonight, our agenda, we'll give you a little introduction to the project and then go into, the first part we looked at was the nitrogen loading analysis for the development in terms of the nitrogen analysis that has been done before by TMDL, the credit land issue. So because the parcel's not large enough to support their wastewater discharge, they need credit land to account for that additional waste. So we'll go into our review of that material. The development is proposing to use this nitro system to deal with the wastewater, and Kate's done an extensive analysis of that system and the history and capabilities, and then kind of go over what concerns we've identified in the nitrogen loading analysis. And then from there, we'll look at, we did an extensive solute transport modeling, which Mark Kaufman will go into that, but it's a conservative model that says if there's discharge in these wastewater systems and it goes to the effluent beds and these are the concentrations and it goes right to the water supply wells, then, you know, these are the potential concentrations you could get in the water supply wells. So we had to develop a conceptual site model, and then we looked at two things. We looked at nitrogen, because nitrogen is the typical impact you see from wastewater to water supply wells, the nitrogen from the discharge. But we also looked at some emerging contaminants, which DEP and EPA have new standards, and they're very stringent, and it's emerging. It's an issue with wastewater, drinking water, hazardous wastes, and then we'll go through some conclusions and recommendations. So the goal of the project, on the right side, you can see this bridle crossing development and the system, and this will go in more detail, but you know, the green square rectangles are the effluent beds for this system. So there's 8 of them on the site. And Kate will go into more detail on this, but basically the bridle crossing development, we wanted to evaluate potential impacts to the town of Marshfield's municipal water supply wells from this development. The development itself, and we'll show you a picture of that on the next slide. The bridle crossing development is approximately 10 acres. There's 56 units with 88 bedrooms. So it's a fairly large facility, proposed to use a denitrification to treat the effluent discharge, which is estimated at 9,680, say 9,700 gallons per day of wastewater. So they're required to do an alternative nitrogen system. They're located adjacent to the Sylvester landfill, which is a cap demolition landfill that we have to worry about potential impacts from there. And then the key to this is they're less than 20,000 feet from the nearest town public water supply.
2,000.
2,000, I'm sorry, thank you. 2,000 feet from the nearest public water supply well. So the big concern is, would this development impact the water supply wells? And then it's within your water resource protection district. So there's specific regs to protect your water supply. So our understanding is the concerns with the development, nitrogen impacts from these alternative septic systems, emerging contaminants from on-site wastewater that we're still learning a lot about, and then long-term impacts to the Littles Creek aquifer there, the town's public water supply wells, from the nitrates, the PFAS, or any other contaminants. So that was the focus. So the tasks we've completed to date, we reviewed and compiled existing hydrogeologic information. We'll go through that. We reviewed the design specs for these alternative nitrogen removing systems to see how, they would affect these areas. Reviewed the nitrogen loading analysis from all this wastewater, the 9,700 gallons per day. Developed the conceptual site model, and then we did preliminary solute transport modeling to determine potential impacts to the public water supply wells. So we put concentrations in and said, what will we see at our water supply wells? So now I will turn it over to Kate to do the nitrogen loading.
Can everybody hear me okay? I know I'm at the front of the room, so if I need to speak up, just wave and I'll do my best. So as part of the nitrogen loading review task, we were asked to review what the developer has already submitted in terms of their design drawings for their on-site wastewater system, as well as a nitrogen loading study, which is a requirement of the town of Marshfield Water Resource Protection District. So this is something that you require when you have a project located in this district. So we reviewed the calculations done by the company named TMGL Solutions. We reviewed the design drawings prepared by Grady Consulting. We reviewed the manufacturer supplied information specifications for the Clean 2 Nitro system, so that's the brand name of their proprietary on-site system. And we also reviewed state regulations as they're applicable to on-site wastewater treatment. And the applicability of that, especially in a water resource protection district, as well as considering some of the newer, they went into effect in 2023, on-site regulations as it pertains to the nitrogen removing or reducing systems. So again, this is another project overview, and for those sitting here in the room, it might be harder to see, but the red outline shows the parcels themselves, and these smaller green squares, if you can see them highlighted, I'm going to move my cursor over the screen, indicates the individual treatment areas where there's actually, this is the groundwater leaching fields for the 8 individual systems. So something that's important to note is Mass DEP has several types of approval statuses. They have 3 different approval statuses for on-site, innovative, and alternative IA systems. So there is general use approved, which as of today meets 19 milligrams per liter of effluent. There's provisional status, which is what the Clean 2 Nitro system meets. That's better than 19 milligrams per liter, so you're looking to reduce more nitrogen from the effluent. They're usually around 10 to 15. Then you have pilot, which are brand new technologies that haven't been as widely distributed or installed, and those are ones that are trying to go below 10 milligrams per liter of nitrogen in the effluent. But that's kind of where you start if you're a technology provider, if you're a manufacturer, you have to go through this system in order to get general use approval. So for Nitro, to kind of summarize their process, they started as a pilot. We'll go to the slide talking more about that particular system. But because Mass DEP has these 3 classifications, they limit the overall size that each individual system can be, which is why this parcel is unique. This development proposal is unique in that they have 8 individual systems to treat separate buildings to not max out the overall site. So the Nitro system can't be used as a one treatment plant for the whole site. These are meant to be smaller systems that are divided by building in this case.
And just to add, the drinking water standard for nitrates is 10 milligrams per liter. So knowing what these discharge at, by the time it gets to your water supply well, it needs to be less than 10 parts per million, but likely even more, because if you already have nitrates in your water, now that's going to add to it. So that's kind of our goal for the systems.
So the other part of Title V, which looks at individual on-site systems, is for a site like this, for a subdevelopment site, the Water Resource Protection District also looks at the aggregate flows, or what the nitrogen from the entire site development will be and the impact of the entire site. So it includes, of course, wastewater, which is considered a nitrogen source directly into groundwater, even through treatment. It is considered one of the biggest forms of nitrogen. Other items that we cover on this include pesticide application, or fertilizer application, for the lawns, roof runoff, parking lot runoff. So this calculation spreadsheet is based on Title V's aggregate nitrogen loading calculations, which is a guidance document that the town of Marshfield has adopted. And again, this is the required calculation for when you are looking to do development in a Zone 2 drinking water area. One of the items that's part of the Mass DEP flow chart when you're looking at aggregate loading on a site is taking into account the big picture of, yes, there's increased wastewater loading, but is there the potential that other areas on the site, such as credit land or undeveloped area, could help attenuate or reduce nitrogen before it goes to your sensitive receptor? And in this case, the sensitive receptor, as Anne Marie said, is the drinking water wells, which are less than 2,000 feet away. So when the developer was looking to propose a type of credit land, they thought they could use this land adjacent to their parcel, which I'm going to highlight on this screen, bear with me. This land here is what the developer originally thought they could use as credit land. However, based on this image, and I'll kind of walk through what the lines were, the groundwater flow model is developed by others. We have this one shown as from Horsley and Witten Group in 2010. Actually shows that the groundwater goes right past that credit land parcel. It's considered adjacent to and not directly down gradient. So if you don't have credit land that's directly down gradient, what that means is you still have to go to the nearest sensitive receptor, which is still going to be the drinking water wells, which are shown actually on this image to the north. So the feature of the developer wanting to use credit land, where that credit land may not actually help you with attenuating any type of nitrogen from the parcel. So what that means is the on-site wastewater treatment is especially important to monitor and meet at the level it needs to in order to make the overall parcel meet its nitrogen loading requirement, because there is no land between where it may discharge and your sensitive receptor. That credit land is not in fact in between, it's to the side.
Can you go back and just kind of show where the public water supplies are relative
Yeah, so we
to
can do,
the site? There's a couple back, I guess.
all right, hold on everyone.
There
There we go.
Yeah.
So this pink parcel in the middle, the one I'm putting the cursor on, this is where the actual on-site systems will be. This other smaller shaped pink parcel is what the developer was hoping to use, planning to use as credit land. What we found out is the groundwater may actually, it flows towards this thinner parcel here. And the wells are up here on this map, as well as some to the south. These are the Ferry Street. So, pardon my big head for you guys can see
And
it.
like I said, they're less than 2,000 feet from the development parcel.
Correct. So now I'm going to skip ahead. Okay, so on this image, because I did say I would go back and show you, these blue lines are essentially showing what has been previously modeled as the groundwater flow for these parcels. So again, you see it's moving towards the northeast, not moving towards direct north or northwest as originally intended, understood, to make that credit land usable as credit land. That's the only reason why I show that. So it's actually moving off the parcel this way. So, as part of our review of the site plans of the nitrogen loading calculations, we reviewed the developer's water resource protection district calculations. This is a spreadsheet that you have available on the Town of Marshfield website. It's a requirement for any land use application to fill out. We checked the requirements, or we checked their calculations, and we found consistent results. So we concur that the TMDL Solutions memo found that the highest total nitrogen effluent concentration that would be allowable on this parcel in order to meet the aggregate loading at the sensitive receptor, also known as the drinking water well, the highest effluent concentration is 14.5 milligrams per liter. So it can't go any higher than that from the wastewater discharge, or else it will bust the 5 milligrams per liter requirement at the drinking water well, 2,000 feet, less than 2,000 feet away from the wastewater site. So what that means is we had to look at the technology that the developer selected is the Clean 2 Nitro system, which they've estimated to have an 11 milligrams per liter nitrogen effluent. And so that kind of leads us into the next discussion, which is how often do they meet that? What's their worst case scenario that they might see in a system? And what are some considerations that the town might take under consideration when permitting something like this, or when allowing this type of an installation to go into place? So, the nitro systems. They, as I mentioned before, they are in the second of 3 categories that Mass DEP has for on-site innovative alternative systems. They basically go downstream of a traditional septic tank. So the way that it will flow is you still collect flow in a septic tank. That's where solids settle or soaps float to the top. And then from that chamber, it goes into the 2-tank treatment units for Clean 2's nitro. There is an electronic component. They do add air into the pre-aeration chamber. Then they have another chamber downstream, so it's a couple different tanks in series to kind of put it visually. The second downstream tank has a carbon source, wood chips, that is treated to help denitrify. So the aeration is where you're seeing the nitrification, and the wood chip section is where you're seeing the denitrification. Then the flow goes out to a leaching field, or in this case, they're leaching trenches that they've designed to go under parking lots, very similar to other on-site installations that you'll have. So they're protected, they're distributed according to the appropriate calculated loading rates, which are slightly higher than the 440 gallons per day per acre requirement. But because these systems denitrify, the loading rate upwards of 550 gallons per day is acceptable because they're denitrifying, if that makes sense. So what these systems can do, we know that there have been over 100 installed in Massachusetts specifically on the Cape and Martha's Vineyard. Some of the first ones have been in operation since 2017, and in 2020 is when this manufacturer got their provisional status. So that's when they stepped up from pilot to provisional. And they have some available installation data from these systems that have been online. This image that I have here is from the multifamily installations. They have 3, so each one of these colors is showing you the different individual systems. This data is publicly available and is to be used for planning purposes only. I can read the little disclaimer at the bottom, but the data you're about to review derives from a self-reporting system for alternative innovative sites in Massachusetts, located in 14 of the 15 towns from Barnstable County. So this was collected by the Barnstable County licensed wastewater treatment operators and is intended to be, it's intended to be for planning purposes only. Essentially, Barnstable County doesn't make any approval or
Verification.
thank you for these systems. So they post the data, but they don't have an interest in one particular brand over the other. Long story short, the maximum values that's shown by the top bar on these box and whisker plots, that's this one here. What's the highest they've ever seen? It ranges between 17 and 23 milligrams per liter of total nitrogen, which is above what the limit would need to be as a maximum on your worst day item. So on their worst day, it would also be our worst day. It would go above the required concentration of 14.5 milligrams or lower. However, the average median of these 3 systems is at 6.42 milligrams per liter. And this data does include year-round data, so it is meant to show for the seasonality for the full year of operation for these systems. To kind of zoom out, what happens for the single-family year-round homes, they do have more that are in this type of installation. Out of the 31 systems that I have mapped here, that dotted line running across the bottom, if you can see it, is where do they stand above the 10 milligrams per liter or lower total nitrogen effluent, and about 23 out of the 31 are consistently below 10 milligrams per liter. So that's 74% roughly of their systems, as demonstrated in Massachusetts. Again, that's the only place where they've had installations to date. So, from the standpoint of can the nitro systems consistently meet the nitrogen levels that they were designed to based on performance data, it appears that if operated according to the manufacturer's directions and instructions, that this will be able to consistently meet, especially for each individual sized, levels of nitrogen at 10 milligrams per liter or below. But again, for this parcel's nitrogen, the aggregate nitrogen loading, the goal to beat is 14.5 milligrams per liter. So,
Can you also touch on the size of the systems relative to the total?
So the other unique factor, and I'm going to step back to this image just again to kind of give you the context of the scale of the site. So when reviewing the Title V documentation, the goal of Title V is to defer to the local approving authority, which is typically the Board of Health, for any type of review or approval regulations regarding on-site systems within the community. So you can always You have to default to the Massachusetts Title V regulations, but if communities want to be stricter than that, it's through the Board of Health that can set more strict rules. The flow requirement is 10,000 gallons per day or less. That is when the local approving authority has authority over the system. As soon as a proposed wastewater flow project reaches 10,000 gallons per day or above, then it's required to go before Mass DEP for a groundwater discharge permit, which has an application process. It's reviewed by the state. It's awarded a permit number and will have operating and monitoring requirements. Typically that requires a graded operator to operate, and it will have discharge limits typical of the area and its needs. So for this particular project, again, it's 8 smaller systems, but together collectively, they're 9,700 gallons per day of flow, which as an engineer, I would say that's getting close to the $10,000 to 10,000 gallons per day threshold. Slip. So that being considered, this parcel is based on the development, or based on what the developer has put forth for the number of bedrooms and units. They don't have any room to increase density, and in fact, the factor of safety puts them right at the maximum before they would go into a threshold of potentially needing to have a Mass DEP groundwater discharge permit, if that makes sense. So, emerging contaminants, one other feature of this study was to look at not only total nitrogen, which is of concern for the public drinking water wells, but also PFAS. As we know, PFAS and all of its components, for this purpose, we looked at PFAS and PFOA compounds, which are the most common, but there is a family of these compounds that you can also monitor. For the purposes of our evaluation, we were focused on PFAS and PFOA species because that was just determined with a final national primary drinking water regulation for PFAS and PFOA. So what that means is the maximum contaminant level, or MCL, was set in April to be 4.0 parts per trillion for PFAS and PFOA. So parts per trillion is nanograms per liter. It is very small concentration, but the number is 4. So just remember that that's the actionable level that the drinking water well would need to take action if they had samples that met or were above 4.0 parts per trillion.
And that's like an order of magnitude lower than any other drinking standard we've had to date. So, you know, it's 1,000 times lower.
And so to kind of step back, I want to note that there are no on-site wastewater effluent requirements for PFAS. So Title V does not have PFAS or PFOA named as a constituent of concern at the moment. That doesn't mean it never will be, just as of right now, they don't have a requirement for that or monitoring that for wastewater treatment. So what we've noted is some studies, because again, we are just recently in wastewater, municipal wastewater treatment plants within the past year and a half, going on, it'll be 2 years this summer, when the first medium general permits were released that included a requirement to monitor PFAS. So communities are just starting to collect data from your regular centralized wastewater treatment plants. But based on some initial studies, what we can estimate is that domestic wastewater influent for PFAS can be as high as 300 parts per trillion. And where we're seeing that accumulate is in laundry residue, if you're washing clothing that's been waterproofed, or if you're using certain detergents, that's where we're going to see it flushed. You're going to see it in your dishwashing if you're using non-stick cookware, packaging that may have, food packaging that might have contained PFAS, and you're also going to see it just based on personal care products, your shampoos, your makeups, your soaps that may have it as well. So that's where, from the human perspective, it's getting into the wastewater. So when we look at where it's accumulating in the wastewater, step back to when I described the septic system and how you have solids that settle at the bottom and soaps that may float to the top. Those top and bottom layers at this point are where we're seeing the highest accumulation in wastewater. So, again, currently, as a reminder, the current drinking water wells, both sets that we showed on that first image, Church Street and Ferry Street wells, are non-detect for PFAS. So what that tells us is there's currently not enough of a background in the wastewater or in the drinking water source at that point. But the concern being, where do we go from here in terms of a 9,700 gallon per day potential parcel and what that may impact for the drinking water wells. So, again, to kind of recap, and I know this is a lot to cover, so I'm hoping that we're jotting down questions as we go. Under Title V, the higher nitrogen loading rate can be assumed. So as I mentioned, the higher than 440 gallons per day per acre is allowable as long as the treatment is removing nitrogen. The nitro system does remove nitrogen in order to meet the higher loading rate. However, the conventional backup needs to be in place in the event that the system doesn't work. So one of the things to be concerned about is, as I mentioned before, the system requires power. If for some reason the power goes out or the treatment components aren't able to run, then the system will operate like a standard Title V system. So there won't be any nitrogen treatment. It will just flow through. It won't back up, but it will just flow through with whatever treatment it can get. At that point, there would be no nitrogen treatment or very little, and it would likely go above the threshold of 14.5 milligrams per liter for that event duration. And when Mark goes through some of the modeling, he'll kind of walk us through quickly like what that looks like in the ground, like what that event simulation might look like. But that's something to consider. The other option is, well, that's for a power outage. What if after 5 years, after 10 years, then you see a degradation of the treatment? What if it starts to not work as well or as efficiently and it's not meeting its total nitrogen in the effluent requirement? Then the town could consider imposing a conventional backup that would be able to meet the requirements of the Water Protection District. And in this case, using a regular Title V system is not allowed because you can't treat for nitrogen. Using a general use approved 19 milligram per liter system also can't be used because it's higher than 14.5 milligrams per liter. So at that point, the town would have two options for enforcing or applying a conventional backup. In this case, for this parcel, it would have to be an equivalent technology to the provisional system, but perhaps under a different manufacturer. You'd have to find another provisional system that can meet an effluent of at least 14.5 milligrams per liter or better. Or mandate a connection to the municipal sewer system via extension, via pump station. Either way, get the flow off of the on-site treatment and into the treatment system. So those are kind of the two avenues for that conventional backup, but again, it's the if and only if, for some reason, the treatment process fails or is starting to fail. Like I said, the nitro systems require external power. So if power is interrupted at any time, then there will be an increase in the nitrogen loading because there will be no nitrogen treatment, no nitrogen removal. Again, we recommend that the developer maybe consider installation of a backup power source. We didn't see a generator of any kind on the drawings, but that could be something that would help power the small aeration components for the system to keep them functioning independently of a power grid outage. And also it would be helpful to the town to be able to understand alarms or notifications so that the water treatment facility can be aware of any changes in treatment so they can adjust operations or switch to a different well system for supply, etc. And then lastly, there's no available information for how these nitro systems treat PFAS because there is no wastewater treatment requirement for PFAS. The PFAS requirement is on the public drinking water side. So at this point, we have some ideas based on studies of where the concentrations could be, and using some of that initial data is what we assumed moving forward to kind of show you what some impacts might be for PFAS if it were to be released in this system, yes. So, Mark, just give me a yell and I'll advance.
Excellent.
Okay, so Mark's gonna go through the modeling we did now, knowing nitrates could be a concern and PFAS could be a concern. How much of a concern is it to our public water supply wells that right now don't have PFAS and have trace concentrations of nitrates?
Trying to turn the volume up.
That's what we're trying to find out.
Can you all hear me okay?
You're coming in on the laptop speaker, so bear with us.
Oh, okay, got it.
This is a new TV, I don't know what a clicker is.
Aren't those speakers?
I might play with this to see, can I switch the audio out to the
Right
TV?
ahead.
Yeah.
All right. Bear with me, Mark, I'm just gonna switch the output to see
I'm a
if I
moron
can
when it comes to this
change.
stuff, so please.
No problem.
Because I can hear you great, the rest of the room can't.
Brian, can you hear him back there?
No, I can't.
Test, how about now, Mark?
I don't know, you guys hear me?
It's good.
Can you hear now,
There
Brian?
you go.
I got it.
Gee.
Yes?
All right, you're in the room. They've got
Excellent,
you.
excellent. All right. Well, thanks, Kate. As Anne Marie said at the beginning, my name is Mark Hoffman, and I'm a senior project manager at McLean Environmental, located down in Princeton. And as Anne Marie said, we've worked with environmental partners for, over 20 years now. Myself, have been involved in projects with environmental partners for at least the last 15 years, I believe. As Anne Marie said, which were, more complex, joint density, kind of groundwater flow and transport, without the Cape. To other kind of zone 2 aquifer studies and those sorts of things. But today what I want to talk about is some of the preliminary solute transport modeling that we did to evaluate and address some of the concerns that have been raised regarding both nitrate and PFAS in the city's proposed development. Just to, when we're talking about solute transport modeling, what we're talking about is basically modeling to look at the transport of contaminants in groundwater. So that's what we mean by solute transport modeling. Just want to kind of put that out there, because this may be a new concept to some folks. But that's what we're going to be talking about today. Next slide. All right, so one of the first things we do with any project, and we did with this project, is we need to kind of look at the available documents, data, and information, and develop a conceptual site model, right? The good news is that, the DPW actually had a lot of good documents for us to review, good studies that were available. In this case, there were several modeling studies that were actually done dating back to the late 1980s. And I feel folks here in Massachusetts are familiar probably with Zone 2s. So Zone 2 studies are basically looking at the area that the well's going to capture water from under extreme conditions, basically, with 180 days of no rainfall, so drought conditions essentially. That tells you kind of the area that you need to be sure that you're protecting, that's been capturing that water from, so obviously you don't want to have any sort of deleterious kind of development within those areas. So there were several Zone 2 studies that were done over the years, dating back to, as I said, back to the late 80s, including studies for the Littles Creek Aquifer, where the Church Street and Ferry Street wells are located, as well as the Furnace Brook Aquifer, so the right next to Furnace Brook, off to the west as well. There's also a number of other types of documents that we looked at to help to develop this conceptual site model, including some of the Silvestre landfill reports. I mean, those have been collected over the years. We looked at the Brattle Crossing development plans as well. We also pulled data from the USGS, including topo data, topographic data to look at surface elevations, stream gauge data to get an understanding of some of the surface water levels, and obviously data from Mass Mapper. A lot of good GIS data we pulled to sort of, put together and get a sense of what's going on. And lastly, some of the groundwater pumpage reports for some of these public water supply wells of interest. Next slide.
Just there.
There we go.
Okay, great, excellent. So we'll get into all the details in the site conceptual model, but the reason we kind of do these conceptual site models is to better understand, what the, sort of the hydrologic boundaries of the floodplain here. So for instance, one of the big ones in this area is the South River. A lot of the water kind of flows, discharges to the South River, flows in that direction. Willis Creek is another one, where you have water that's kind of flowing towards Willis Creek. Some of the surface water divides. Here you have these Telegraph Hill and Carolina Hill, which affect groundwater flow as well. You want to understand that. You want to understand the aquifer conditions. So basically, what are the aquifer parameters? Hydraulic conductivity, hydraulic gradient, which is sort of how the groundwater surface is changing as it goes across a certain distance. So based on that, one of the key takeaways from in looking at this conceptual site model, looking at the various studies that have been done, and I think Kate touched on this earlier, in her talk, is based on measured and modeled, groundwater flow conditions. It appears that groundwater is flowing sort of an east-northeast direction. I want to one point of clarification is the Hersey-Witten map that we're showing there. The contours developed by Hersey-Witten back in 2010. They're not modeled. That's actually measured data. So that was actually gauged water levels that were collected as part of a study that was done for the Sylvester Ray landfill. And you can see those little pink dots represent the different gauging points. They had several monitoring points that they used to kind of gauge those water levels in those locations. And this seemed to be consistent with one of the more comprehensive modeling studies that we looked at, which was done by CDM back in 1991. This was some of the models that were done were pretty simplistic, so single one-layer models, pretty simplified assumptions. But the CDM model was multiple layers, very complex. We looked at a number of different scenarios that they modeled, and it's tough to see. Unfortunately, since it is from the early 90s and probably been copied multiple times, the little graphic down there to the bottom, you can kind of see those little darker areas there represent the capture zones. The one to the north represents the capture zone that they modeled for the Church Street and the Ferry Street wells. What you can see there, it's difficult to see from this, but essentially groundwater is being pulled, so it's kind of migrating down off of Carolina Hill there to the east, and then being pulled in. So as it goes east-northeast, it's getting pulled into those wells as it kind of hits that lower permeability material over near Telegraph Hill, which is kind of, you can't kind of see it there. You can see it says TEL on the side of the graphic there. But as it does, it's kind of pointing into those wells. So point being is that both the modeling studies, the measured water levels do seem to indicate you have this northeasterly flow that sort of, works its way around, gets captured and pulled in by the pumping influence of those wells, the Church Street wells and the Ferry Street wells. Next slide.
And one more thing on that one. I'm going to go back for 1 second. Those purple lines show you the limits of your groundwater protection district. So anywhere, anywhere in there is your the regulations apply for groundwater protection.
Right. Yes, and that's not one you point out. That's a good point, Emery. That one's for the Church Street, Ferry Street wells, and then there was one off to the east that kind of overlaps with that, but that is for the Furnace Brook wells that are located off to the west. Huh? Thank you. All right, so once we sort of, got our bearings and sort of got some, necessary data and information to conceptualize, groundwater flow conditions, hydraulic parameters, those sorts of things, we wanted to do some preliminary site fate and transport modeling analysis to, first to examine potential concentrations of nitrate and PFAS compounds at distances coincident with the northern credit parcel boundary that Kate talked about earlier, as well as the Ferry Street well one, which is the most nearby well to the development parcel. To do this, we use a software called TS10. It's a site transport modeling software, which is actually a library of a whole bunch of different analytical and semi-analytical solutions, models, I guess, if you will, that have been developed over the years, been published, and they are solutions to the effective dispersion equation, which basically governs the fate and transport of contaminants in groundwater. And for this particular analysis, we used a model called AT123D-AT. I know it's a mouthful, it's a big acronym, but essentially it was developed originally back in the early 90s and then updated back in 2012, this version, to deal with some irregularities that were identified in the original solution. So it's a pretty accurate solution. But basically, the benefit of it is that what it can do is it models a horizontal patch source at the water table. So imagine, you can see up there to the right, and Kate talked about this, you have the parcel, the development parcel with those green boxes which represent those leach fields. And so the water is going to discharge into the subsurface beneath this parcel. So what this model represents is you have this, off the water table, you have this patch source that's taking into account two things. It's going to take into account obviously the area, that comprises this development parcel where these infiltration beds are located on. And then it also takes into account the flow rate. So we talked about that. It's about 9,700 gallons per day. They're coming into the subsurface. And then what concentration of, the solute of interest. So whether that be nitrate or PFAS. So you have 9,700 gallons a day of water that might have a certain concentration of those compounds. And we call that contaminant mass flux. So AT123D looks at the mass flux of those contaminants into the subsurface at the water table and then carries them down gradient in the aquifer to see where they go. Now for the model input assumptions, obviously those based on the information from our site conceptual model. So the hydraulic connectivity values were obtained from some of the aquifer studies. So we had pump test reports. We had some of the modeling that was done, so we kind of looked at the range of those values and chose a conservative value of about 90 feet per day. Same with hydraulic gradient. We got that information from one of the previous Zone 2 studies. So again, it's pretty conservative in that basically you're assuming, these drought conditions. You have, more significant drawdowns around those wells, the pumping wells. Information from the proposed development, obviously the discharge rate of 9,700 gallons per day. We ended up doing 4 different scenarios, and I'll talk about those in a minute, but we did 2 scenarios to look at nitrate, and 2 scenarios to look at PFAS. Next slide. One thing that I do want to mention is these scenarios that we did perform are pretty conservative. So this would be conservative for a number of reasons. Number one, we just talked about groundwater flow directions, right? And we talked about groundwater appears to be kind of flowing more of an easterly, northeasterly direction and then kind of sneaking its way and getting pulled back around into those wells. But to be conservative, what we assumed for the purposes of this analysis, we assumed a direct pathway to the Prairie Street 1 well. So basically, sort of like that graphic I think was in the design drawings that shows this direct kind of conduit going from the development parcel down to the Prairie Street 1 well. We assume a relatively high rate of groundwater velocity. So again, based on that higher end conductivity value and then the hydraulic gradient value that was used. The other thing to note is that these analyses assume for both PFAS and nitrate, there's no degradation going on. So sometimes these compounds, like nitrate in particular, might degrade as they go through the subsurface in the unsaturated zone in the soil, and then they get to groundwater, and then within groundwater. But to be conservative, we assume no degradation in these compounds. Same with retardation. So retardation refers to as these molecules of these compounds that are dissolved in the groundwater make their way through the aquifer, they can absorb onto the soil and the aquifer materials. And as they do, that kind of it has the net effect of sort of slowing those compounds as they migrate through the aquifer. But in this case, we assume no retardation. So none of this stuff is sorting. It's all kind of going through the aquifer, not sorting. We also assume that no nitrates currently present in groundwater, from other sources. Not necessarily, that's not necessarily a conservative assumption, but just to put this in context, what we're looking at are the concentrations just from this, these infiltration beds. But the other important one is that these conservative analyses don't take into account potential mixing of clean water at the wellhead. So you kind of see what I mean by that in this kind of simple graphic down at the bottom here. What this represents is a very simplistic look at if you see a well capture zone, so those little red and purple lines extending back from a pumping well, essentially. They're pulling in water. But you can see that little pink area might be representative of a contaminant plume, for instance. So when that well's pulling in all this water, it's pulling in both, quote unquote, dirty water from the plume, but then also clean water. So that is going to have the net effect of kind of when you blend that together, those concentrations that we're looking at the plume might be further reduced by the clean water that's also pulling in. Next slide. All right, so the first analysis we did, the scenario one for nitrate, and we assumed sort of under, normal operating conditions. So we assumed kind of upper bound estimate of in the discharged effluent into these wastewater beds of 10 milligrams per liter. So basically a constant concentration, over, I think the analysis we did, we looked at, I think, just over 10 years, for just to get an idea of what those concentrations would look like. And what this plot shows is in the bottom, on the x-axis at the bottom there, is the time. So we get time in days, and on the y-axis, the vertical axis, is the concentration. And the blue and red lines represent these two observation points down the gradient from the actual source. So basically, where the wastewater is being discharged. So the blue line represents the northern credit parcel boundary. So what you're seeing there is the concentration at that northern credit parcel boundary that's predicted by the model. The red line at the bottom is coincident with the distance equals, of the down gradient Ferry Street 1 well. What we can see from this under normal operating conditions is that the concentrations, at that down gradient location near Ferry Street 1 well are only up to about 2.5 milligrams per liter. So definitely below 5 and definitely below 10 milligrams per liter for that evaluation. Next slide. So this is sort of another plot that you can use to kind of look at these, the output from these models. And this is a contour plot, essentially. So this plot, the x-axis at the bottom, is distance. So we have it, and that's in feet. So you can see here, we have the distance in feet at the bottom, and on the left is basically the dimensions on the y-axis of, basically, that's also distance. That's in the y direction. So that basically, what we're kind of looking at, so the left to the left here is essentially to the south, and then to the right would be to the north. So basically looking, sort of moving up to the north towards the wells. And that red line here represents the actual approximate distance to that Ferry Street 1 well from the model source area, or the origin of this plot here. And then you see the blue represents the concentrations up near the effluent beds and immediately downgraded from them. You can see that that outer bound represents about 5 milligrams per liter, and it doesn't extend anywhere near the Ferry Street 1 well under this scenario. All right, next slide. The second scenario, the one thing we need to look at, because there's been some concerns as to what might happen if you had a complete failure of the denitrification system. So for this evaluation, what we did was we started a source, again, the effluent water, 9,700 gallons per day, at a concentration of 10 milligrams per liter for a period of about 500 days, which is just arbitrary. There's no, specific reason for the 500 days. It's basically, so you have the source that's been, discharging for about a year and a half or so, at about 10 milligrams per liter. Then we assume that the system fails. And at that point, for a period of 30 days, the concentrations are increased to about 100 milligrams per liter. So assuming there's no treatment of that wastewater effluent. Then after 30 days, it's assumed that that system is repaired, and we're back to 10 milligrams per liter after that period. And what this analysis shows, you can see that blue line that represents our northern credit parcel boundary gets up to about 12.5 milligrams per liter. You can see that blip there. So we have this spike in concentrations right near that parcel boundary. But as we migrate down gradient towards the where the Ferry Street 1 well is located, you can see that the concentrations, we also see that sort of spike, but then it gets up to about 4 milligrams per liter at that location. All right, next slide. All right, so for PFAS, one of the things, I think Kate talked about this a little bit, that there's been there's not a lot of information out there, but there are studies that have been done for municipal water supply systems. And one of those studies, or some of the studies we looked at, indicated that, for PFAS, and specifically as Kate mentioned, we're looking at PFAS and PFOA in particular, that, some of those showed concentrations in the effluent about 24 nanograms per liter. So we plugged that into the model. We assumed a source of 24 nanograms per liter, 9,700 gallons a day, similar to the other analysis we did for nitrate, and ran that forward. And what this actually shows is, you can see down here at the location coincident with the Ferry Street 1 well, that it actually gets up about 5.5 nanograms per liter. So it exceeds that 4 parts per trillion or 4 nanograms per liter concentration at that 24 nanograms per liter constant concentration under that scenario. Okay, next slide. So this is, this is a concentration contour plot. And what you can see here, you can see this plume that's kind of emanating from that source zone, the ground gradient, and then that red dashed line represents the well location. So you can see those concentrations actually reach the well here above 5 nanograms per liter under this scenario. Next slide. All right, so once we ran that analysis, the question came up okay, if we look at it at 24 nanograms per liter, what is the threshold concentration under these, again, using these conservative assumptions at which PFAS could make it to the well, what is the threshold concentration in the effluent discharge that would result in potential exceedance at the down gradient location coincident with the Ferry Street 1 well? And the way we did that is basically dialing back the concentrations that are in that wastewater effluent until we get a concentration at that down gradient location that is just above, or just exceeds that 4 parts per trillion standard for PFOA and PFOS. And what that comes out to be is about 18 nanograms per liter under that scenario. Okay, next slide.
And so just the 4 milligrams per liter, above that, DEP would require the town to do water treatment. You'd have to have a PFAS water treatment system for the water supply wells.
Right. And this is just, again, the sort of contour plot showing that. So you can see right down there, the red line sort of at the distance that's kind of coincident with that 4 parts per trillion line that we kind of dialed in from that scenario. All right, next slide. So just to wrap up and kind of summarize the results of these preliminary solute transport modeling analysis we did. Number one, as part of the CSM development, we looked at a lot of different studies, and based on the review of that information, as well as some of the measured, groundwater elevations that have been collected in the vicinity of these parcels, it appears that groundwater in the vicinity of the crossing development parcels flows to the east-northeast, which, as Kate talked about earlier, indicates that that credit parcel is likely side gradient of that development parcel. Now, based on the conservative preliminary solute transport analysis we performed to look at the concentrations of nitrate and PFAS at these distances coincident with the Ferry Street 1 well, it does indicate that you're going to get concentrations of nitrate at the Ferry Street well, and potentially the Ferry Street wells as well, that are likely to increase. So what that means is you're going to see some nitrate increases potentially from these discharges. But from these conservative analyses, it indicates that those nitrate concentrations don't appear likely to exceed 10 milligrams per liter. In fact, they could be even, based on the results we have here, they would likely be lower than those too. But there will be some increase in nitrate concentrations expected at those wellheads. Conversely, though, the analysis indicate that you can have relatively low concentrations of PFAS in that discharged wastewater that could result in those compounds reaching those wells, those down-gradient water supply wells, at concentrations that could exceed that really low standard that we already talked about, at 4 nanograms per liter. So for this analysis, we estimated, that threshold concentration to be about 18 nanograms per liter under those, again, those conservative assumptions we used. But keep in mind, Kate talked about some of those other studies we've done, and I know for PFOA alone, some of those studies have shown about 78 or 80 nanograms per liter. I think the total PFAS is still like 300. So the point is, it doesn't take much, for those concentrations to, start to get close to that standard of 4 nanograms per liter. Especially since PFAS, doesn't really degrade, and it really doesn't seem to sorb to these aqua materials, unlike some other compounds. All right, with that, I'll turn it back over to Kate to wrap up some recommendations.
Thanks, Mark. So again, to wrap up, recommendations that we have for the town of Marshfield while reviewing this proposed development include absolutely continuing monthly reporting for the nitro system beyond what is the minimum required under the Mass DEP provisional permit that manufacturer has to do. So the manufacturer is required to do 12 quarters of monthly testing, and then afterwards, it's only quarterly testing unless there's an issue. If the system performs, then the manufacturer is allowed to stop testing. But what we're gonna recommend is that you just continue to test, because nitrates are still a concern, and you still want to be able to understand that system is functioning accordingly, because it is less than 2,000 feet away from your sensitive receptor, your drinking water well. If for some reason you find that the performance exceeds 10 milligrams per liter of total nitrogen in the effluent from that monitoring, that the conventional backup plan would then go into effect, and that would be enforced by the town of Marshfield. So whether it's determined to be an equivalent system replacement or mandating a connection to the centralized sewer system, that would be something for the town to consider as a performance restriction for this on-site system. The other item was, again, our recommendation for the secondary backup supply. As Mark showed, the up to 30-day power outage will still keep the system within the denitrification criteria. It will still remove nitrogen, but there is still that temporary short-term impact that can be felt from a power outage. So consideration of having a small generator to be able to power only those treatment components that are needed will just help ensure consistent, high-quality effluent to the drinking water wells. And then, as we mentioned, there's no available information from the wastewater treatment perspective from the manufacturer for what PFAS we could expect to see in the effluent from this wastewater treatment on-site system. So while relatively low concentrations discharged in the wastewater may be attributed to long story short, the on-site treatment components of where the PFAS concentrations would be found could potentially be removed by pumping the septic system more regularly than you would a typical Title V system. So if we know that PFAS might accumulate in the solids and the soap layer, that if you're pumping out that first chamber more regularly, that would help reduce any potential downstream. However, what we found is you could have as low as an 18 parts per trillion influent amount, which would reach the maximum contaminant level or the actionable level for the drinking water source. So at that point, the town would be required to implement a study and pilot testing for a media treatment or for some sort of process to treat PFAS in drinking water. And from what we can tell from other projects, that would ultimately be a permanent impact to the drinking water treatment. And again, Title V doesn't require sampling of PFAS, nor are there any on-site wastewater treatment requirements for PFAS. So through whichever mechanism the town decides, whether that's utilizing your water resource protection district or utilizing your existing town bylaws as it pertains to the drinking water PFAS source, we'd strongly consider you to consider what that might look like for the town to implement a more stricter monitoring requirement for PFAS, especially from not having very low concentrations, from having very low concentrations or trace amounts of PFAS right now. Some recommendations for next steps that we have are to, as part of our work, we do have a line item to create a groundwater monitoring plan as part of this site, so that's something that we can continue and look into as well.
And one other thing that's not up there, because the wastewater group at DEP is really focused on public wastewater treatment plants, the bigger sources. We may want to also talk to the drinking water group at DEP, because we're concerned about your drinking water wells and protecting those from needing any sort of PFAS treatment. So approach DEP drinking water and say, this is the situation, this is what we've modeled, and do we, you know, do you have recommendations, or what have you done at other sites to see how they would approach something like this?
Okay.
So with that, we'll open it up to questions.
Okay, so,
Comments?
I want to thank the consultant for all that. I would open up to questions to the board first. Town council, I know town council has to go to another meeting. Board members. It's a lot to think about and a lot to understand. And, you know, we're going to have to come up with a list of conditions to, a letter from this board through engineering and the consultant of what we want the ZBA to consider if and when this proposal gets approved or not. So we're going to have to put something in writing to the ZBA. Diane, any comments?
Well, the PFAS, recent PFAS laws, you know, through the EPA and the DEP, do you anticipate that they're going to be looking at wastewater soon to implement requirements there?
That is a great question. From what we can tell, and again, they usually are holding on to that information as to not cause alarm, and because we do have concerns about the cost it would take to upgrade for like centralized wastewater treatment facilities. But in the past, historically, if EPA has asked for or required monitoring of certain components in wastewater, it typically is indicative of a future permit consideration. So for example, phosphorus and nitrogen were 10 years ago being monitored. 5 years ago, they got entered into permits for many centralized wastewater treatment facilities. So if we're using historic context, then yes, it is likely that they will. But we don't have any timelines confirmed from the regulators yet.
And then my other question is the 9,700-ish volume. I mean, I know that's based on percentages, but how likely is it that that goes over 10,000, even though this is based on their model of the system and then percentages that each unit would have?
So the 9,700 gallons per day, the developer calculated that based on Title V flow estimates for bedroom flow. What we're finding in real life and practice is that the flow will typically be lower than that. So the 9,700 is the design maximum, essentially, or the higher end, the more conservative side of capacity, because we have flow fixtures and more energy and water efficient appliances. It does tend to, in practice, end up being lower. But again, that's also assuming that the systems are being operated in accordance with rules and regulations about what you flush or not. So as long as no one's dumping large quantities of who knows into their toilets, then it would likely stay within or below that 9,700 gallons per day. But you're right, there isn't necessarily, other than significantly increasing the units, which is not, it's 88 bedrooms, that's what they have. It would likely stay within that.
Okay.
And then the other factor could be if you have less water because your, you know, washer dry, your washers don't use as much water, could be higher concentrations of PFAS in that discharge water. How would that affect it?
And nitrogen too. The lower flow, it would be a higher loading or a higher concentration,
Okay.
less dilution.
That's a good thought.
Okay.
I think that's all, the only questions I have right now.
John, go ahead.
So, you mentioned it makes sense to have this developer have a power supply, a generator, to, just in case they lose their power. So that's something that we should consider in
Conditions.
Conditions.
yeah, condition to the ZBA. But also, you mentioned on the maintenance that the manufacturer would be there 12, was it 12 quarters or something of that nature to make sure that this system that they've developed is working properly. And then if it is working properly, it's less so-called check on the maintenance. Well, who's checking on the maintenance people? That's my question, is who's checking on, and who is it? Is it the manufacturer or somebody that they're subbed this out to? So we need to know that information, because it seems to me that they're probably subbing out to something and we wouldn't have control. So we gotta find out exactly what they're gonna do for maintenance, who's gonna do it, when they're gonna do it, and they have to notify us when they're doing it. And then when they want to do less, we want to know more.
Well, one of the conditions could be that, that they don't stop after 3 years, they continue on. That was their recommendation.
Yeah, I'm just,
Right, and also the flip side of that is who's going to do it and how is it going to be done, and the department needs to know.
yeah, because they could do a two-step, you know.
Right.
This did it, this one did it, that one did it,
Right.
and then you don't know who did it.
So we need the contractor to be responsible.
And do they need to be licensed? Do they have to have training?
Mhm.
You know,
They're gonna record it all.
There's a lot of ifs on this system, and who's gonna maintain it? I did read something about it and found out that they have to be maintained. So that's some of my.
That would be a certified wastewater treatment plant operator.
Yes and no, but it would fall under the Board of Health as well.
Yeah.
Just to add to that, the nitro system, because it still is under the provisional Mass DEP status, the design documents from the developer have in detail what some of the other reporting requirements are that nitro has to the state, which the town would want to be included on as a CC or be included in that. But to start, it is, yes, the 12 quarters, the 12, or at least 12 quarters of monthly reporting. And then they do require that there are contracted services from a certified wastewater treatment operator. And I believe they require grade 2M or higher, but I would have to check the permit specifically to see. And it is in the nitro, so Clean 2's nitro provisional permit, it has some of those requirements in there. So if the town wanted to consider something more stringent, where you wanted it to be, continue to have those contract services also after whatever the minimum timing would be, then that would be something to consider as well.
And that was one of our recommendations, to monitor for the life of the system,
Right.
just to ensure you don't have any breakthroughs.
So all our wastewater technicians are grade 4 and above, so they would qualify.
Okay. So did anyone write any questions out?
I didn't write one out, but are you guys gonna?
Okay, so let me go through it. Name and address for the record.
Brian Murphy, Elm Street, CBA. Are you gonna, this information going to get sent to us so we can share it with our consultants and put it on our website or your website? Are you gonna upload this?
Yeah, so we're gonna work with the consultant and Rod to come up with a list of conditions that we were looking for, and that the board will look at the conditions and then send the ZBA and the Board of Health a letter saying exactly what we'd like to do to protect our water supply.
But is this information that you're showing tonight, is that gonna be available to us and our consultants?
We can do that, right, Kate?
Yeah.
We can make it available, yeah.
Yeah, like an email availability.
Sure,
would
just like a
have it,
copy of it. And then is there any chance at our next meeting that a representative from the Board of Public Works and environmental partners could come to our meeting to explain.
When is your next meeting?
28th.
May 28th.
28th is a week from,
Is that tomorrow?
Week from Tuesday?
yeah, next Tuesday.
28th.
May
This would be
28th.
nice to have.
That's the zoning board of appeals, that's, he's the chair of the
Just a good
ZBA.
explanation.
So Anne Mary, could someone come from your firm?
Yeah, we could do that.
Well, we'll have someone there and I will be there.
All right. Just because it's a good presentation, I think it would be helpful to my work.
Right,
You did a nice job.
Yeah.
okay. And would you want the full presentation again?
It wouldn't hurt.
Okay,
It's a good presentation, you know, there's a lot of information, I mean, as your board can see tonight, that you have to disseminate.
right, there's a lot of issues on the nitrates, but it's even bigger issues on the PFAS.
Yeah, I just said it's something that our board should hear.
Okay,
Video.
Can you get access to the recording and put it online?
so we can put the video that's online,
Yeah.
online,
Yeah.
so people can see that also.
Yeah, I mean, if you could have that and they can see that before the meeting and they can give us the, you know, abbreviated version of it, at least they'll have already seen the whole presentation.
Right, we can do that.
That'd be great.
Okay, so I'll go down. Dave, you had your hand up second.
Yeah, I have questions, but
Dave
with
Carey.
my penmanship, Dave Carey at 34 Outlook Road, with my penmanship, I will turn these into an email to Rod so that it can be corresponded to you folks and also to the consultant.
Okay, great.
Yeah, but I do have one question right now. The PFAS, as you mentioned, were the PFOA and PFOS. But we are required by the DEP for the water to monitor the 6 PFASs. Yeah, I guess, why were those included in any form in the study?
Great question. For the modeling scenarios,
Yeah.
we selected only the PFAS component and just the main species, the more common species.
Yes,
So
I
no, the
understand.
other-
Yeah, I'm pretty well up to speed on this stuff, but the other thing is, right now, I do know that wastewater plants are being asked to monitor 16 of the PFASs, you know, by the DEP. And my only dog in this fight, so to speak, is that while I was on the Board of Public Works, we drafted a bylaw that said you will not bring PFASs in during construction or maintenance. And one thing that caught my eye was your mentioning of the fact that they're using a carbon effect, which basically is wood chips. And lumber is one of those things that has been listed as having PFASs. And the other thing was mentioned in one of the prior meetings that I will include in here is they indicated that their tanks were lined with plastic in the nitrogen operating, reducing units. And most plastics, of course, contain PFAS. And, you know, the comments we've had to date typically on that sort of stuff, and this is not part of your study, but it's the only dog I got in the fight.
It's a big dog, too.
It's getting bigger.
It's getting bigger.
Barger,
I mean, you know, EPA's involved with it,
Yep.
and DEP.
Yeah, I mean, you know, the tightening and the rationing down of all of the concentrations of what's happening. The day will come when it is in wastewater treatment,
I mean,
both for septics and sewer.
the state and federal regulations haven't even, you know, got a handle on what they're putting in. I mean, this is the advent of it.
And part of the reason I mentioned too, on the other PFASs is there are studies out there right now saying the lesser PFASs combined with the PFOA and the PFOS and the Gen X seem to lead to more rapid disease issues.
Yeah, and the study that, you know, we did look at a study done in New Hampshire that looked at like 70 different PFAS
Yeah.
or something, or 40 different PFAS.
And Maine went wide because they had to after poisoning a whole bunch of dairy farms.
And then this was a site in New Hampshire,
Yeah.
so do not cite or quote, so we won't go into the details, but they looked at a system very similar to nitro, where they had the denitrification chambers and they were sampling right there at the denitrification, right before it goes out to the leach fields, so.
I'll get you in a second. All right, Dave, you all done?
I'm done.
Okay. Name and address for the record.
Mary Taylor, Grove Street. I didn't see anything in this presentation about groundwater flow after the proposal this particular proposal has a component where they're talking about excavating 125,000 cubic yards of soil, and I didn't see anything in the modeling that explains what will happen to the flow of water should that parcel of land be removed. And it changes the topography, and that's right up against the landfill. So that's been a question I've had all along, and I thought this was going to include that information. I thought that there would be some modeling
So
regarding.
actually there was.
Did I
It
miss?
just wasn't presented. Mark, you want to take that question?
Yeah, that is something we looked at, and there was concerns were raised about that issue. Keep in mind, we're talking about groundwater flow modeling, the material that's being removed is the unsaturated zone, so it's what we call the Vados zone. So basically, and then what we're talking about is that large, sandy, powdery material that's going to be excavated as part of this. Now, what that's going to do, I think the net effect of that is it's going to reduce the distance to groundwater. So that has implications for when you have those infiltration beds. If they're closer to the groundwater table, that's less attenuation that might occur. So as the stuff migrates down from that unsaturated zone, like nitrate, for instance, a lot of times what happens is that absorbs the soils, it reduces the concentrations that reach the groundwater. So you have that effect. But as far as groundwater flow directions, that's not really going to have an effect on those necessarily. Remove that material. Now, I think this came up before. Is that when you remove that material, we don't have a full understanding of everything that's in that so that's why landfill. So I'm not sure if that's going to cause any sort of I wouldn't anticipate that it would any sort of effects on those wastes that are in there and kind of shifts in the subsurface. But as far as what we know today, removing that material, aside from reducing that distance to groundwater, doesn't appear likely to affect the groundwater flow directions in that area. Now, I think Kate mentioned one of the things that we do want to kind of, we talked about this with, some of the folks at DPW about this, is coming up with a monitoring plan, groundwater monitoring plan to kind of look at that issue specifically. So making sure, if we install a well and we have a well that's kind of located at that, downgrade boundary of the landfill, so we can kind of monitor any potential changes that may occur as a result of that. But right now, I'm not expecting to. The other site we've seen, as far as groundwater is concerned, has been sampled in the wells that have been completed near the Celeste Area landfill. Didn't really show the presence of any compounds, of concern.
Are they tested for PFAS?
I wouldn't say any testing for PFAS though, so that's a good question.
That's a good point.
Any other questions on this side of the room? Great.
Marcia Ballou, Ferry Street. The conditions that, the list of conditions that will be put together based on this report, will those conditions be conditions that have to be met, but who would pay for those? The town of Marshfield or the property owners?
Both.
Both.
To be determined, depending on the conditions. I mean, if it's wells and century wells that are on the property line, on town property, and it's a benefit to us to determine if there is something coming off, then the town may require the developer to contribute funding, but it'd be on town properties, it would probably install those. That's why I say both.
Okay.
All right, it's to benefit us. We're trying to protect our water supply the best way we can.
Right, and the testing, the testing that goes on, that's the requirement of the manufacturer of these septic tanks, or is that the town?
The 3-year window would be the developer.
Lifetime.
Would you put the condition as a lifetime? Is that?
Yes.
But that does not include PFAS because that's not allowed at this point. So nitrogen, those are pretty cheap costs for monitoring.
What if we had a 10-year drought and it's just the opposite? We don't have enough water. And this property requires, it feels like that this property requires water to stay safe. So if we go into a situation where we have no water, we're in a drought, like we've had previously where our wells were, I know our wells weren't in jeopardy, but we were careful, we were asked to be careful. What if that happens and that becomes prolonged? How does this system manage then?
So that was, we included that as a phase 2 scope of work. So if we want to take it to the next level, we have the capabilities with our model, but that hasn't been done yet. But that is a concern that we've had too. Under zone 2 conditions, that's what zone 2 is, 180 days with no rainfall, no recharge to the aquifer. So that could be looked at in a detailed model.
It would seem that for the town and future projects and that, you know, the assumption that maybe we might have a drought, that would be part of the considerations as a backup situation, since these high-tech systems require water. And that seems to be a concern. So how do we put that as a condition?
Hey, Mark, could you address that? Did you hear that question?
I'm not quite sure I understand it, to be honest. So you have drought conditions, and you're saying that systems require water. The systems basically are, what goes in there is basically water that's used, is wastewater from these residences. So when you say that it uses water, could you elaborate on that a little bit?
Well, it seems like the water going through these filter systems, if minimal amount of water is used, these filtering systems may not be as effective for nitrogen. I don't know.
So you're talking about higher concentrations. I think they talked about that. And then,
Plus pulling, the well's pulling.
That's what I thought she was asking.
It seems like it's
the
it seems like
gradient
the
might be a little bit more and it might get to the wells quicker. Is that what?
Yeah.
It seems like the contradictory theory behind, it seems like the contradiction to what we're talking about. I might not be making sense, but it seems like that option needs to be in place, because if they do become higher concentrates, and that's not even the PFAS, then it seems like that could be a heavy-duty expense for the town, for all projects, not just this one, any project where something like this is used in the filtration system.
All right.
I might not be making
Yeah,
sense.
No, you're
so I'm
making
thinking
sense.
like
I mean,
we're in
the issue
drought
is,
condition.
if it is a lower flow, there's a higher concentration.
Yeah.
And what happens if there's, and you just brought it up, if it was less than, the 9,000 gallons, if it's 7,000 gallons, but the concentrations are higher, then you're getting a higher impact out into the aquifer. And if there's less water, recharging it, you're getting even a higher impact.
Well, and I think it might have an offsetting effect though. So remember when I was talking about mass flux? So that's basically, when you take into account the actual discharge rate of 9,700 gallons per day and the concentration. So if I reduce that discharge rate, but I increase the concentration, I could end up getting the same amount. So it might be like, less flow, but higher concentration, but the end result might still be something similar. I mean, you have to look at what those expected concentrations might be if there was lower flow in those wastewater systems. But I don't think we have data that's that granular on that. And then one other thing is the thing that's coming to this discussion too, I wanted to mention, is for the solute transport modeling analyses, the gradient that we used was based on zone 2 modeling that's been done. So that's what I was saying, they're conservative, they use this higher barometer velocity that's under those zone 2 conditions. I think we're talking a couple of different things there, the concentrations, the lower flow in the wastewater system, and then we're talking about the stronger pool of the wells, under those zone 2 conditions. So I think there's two different things being discussed there, but that's sort of a little bit on each of those.
And I think like.
Anything else you want to add? No? Oh, any other questions? Anne Marie, you had a question.
I had a question, Anne Marie. I live in Silver Pine. In that provisional system, the figures that you came to as far as discharge, is that based on, is that taken into consideration any landscaping that's gonna happen in the future, all the chemicals put on to maintain this type of property? Was that taken into consideration? Because that's gonna be a lot. And also, as one of the commissioners mentioned, what about the maintenance of this system? You have wood chips? Wood chips. Are they gonna replace periodically? And as Dave said, they tend to hold PFAS. Also, the study that was done on this provisional system, you said in a couple of locations down the Cape or whatnot, but you have to understand too, in those locations, it's not as a concentrated population here. We're here. It's changed. 24 or 25,000 people have started to be full-time residents. Down the Cape, on the Vineyard, I don't think those are correct comparisons as to what is going to happen in this town for that system. And another thing, we lose power a lot. The most of the time we've lost the length, six days. And you're going to tell me that that system will be functional for 30 days and everything's going to be fine in that well. And you'll say the town will have to say, you keep saying the town's going to have to, the town's going to have to. If that system fails or whatever goes wrong there, we're going to carry the burden of it. It's all very disturbing, all of this. And there's no generators. We've asked them at the zoning board about having generators as a backup system, and the board has mentioned we should have them, but they kind of fluffed it off. Are you kidding me?
Keep at it.
So, right, did you get all that?
Yeah.
Okay.
Some of it.
Some of it, okay.
Well, I may not speak all that well, but I have a lot of passion and it's very disturbing that the town has purchased many properties around this particular area just to protect that land, and we're actually going to consider putting a development right smack on top of it. And the guy who bought it, well, buyer beware. He bought it, and it's his problem. It's on the assessor's map, it's considered unbuildable. And now here we are, threatening our water system, and water is a huge issue in the whole globe. And we're going to threaten those wells. It's a disgrace. It really is. I'm sorry, but I have to vent somewhere.
That's okay. We're all venting.
Yeah, and that's where we came out with the PFAS study.
Yes, Dave has been, in the board in the past, has been very cognizant of PFAS issues, and I do work at the wastewater plant, and we are testing for PFAS down there.
Good to know.
So it's coming.
Yeah.
It's here.
Okay, any other questions? I don't want to, before we wrap up this?
Seeing none.
No? John?
I'm good.
Diane? I want to thank the consultant. We'll be working with you to develop a list of conditions to give to the ZBA. And Rob will talk to you about what we can give as a presentation, an abbreviated presentation to the ZBA. I want to thank everybody for coming.
Thank you. Thank you. Thank you for doing all this.
So let's go on to the rest of our agenda. Okay, one of them. Yeah. Thank you, Mark.
Everyone, have a good night.
Thank you.
Thank you so much, Kate.
Okay.
Thank you very much.
At our last meeting, we had a discussion about, John, you brought up the issue of a new bylaw within the town about, okay. I want to get everyone back to this meeting. Right. So we're going to go back to our regular agenda.
Video.
So, okay. So at our last meeting, we had a gentleman here from Windsor Wilson Road. And we didn't have it on the agenda, so I put it on this week's agenda because I said I would. And the issue is, the Board of Public Works, rights of way on the road relating to driveways on either side, including poles. And that's what John Kuzak had brought up, that the town has, the Board of Public Works has control over that. I wanted to have town council have a discussion on what's the limits of our right of way, but he's not here. So, and is there anybody from Winslow Road, Winston Road, here to discuss this? Since I don't see anyone from Winston Road, do we want to discuss it, or just pass it over? Pass it over, good. So the next item is superintendent's report.
Okey-doke. 2 meetings ago, the board had asked me to write up an amendment to the water restrictions and add the building commissioner.
Oh, right, that's right.
So what I wrote,
For town meeting.
see if that's good enough, and I'll submit it. Because we're gonna have a special town meeting in June, so I might as well get it on now.
I understand. It's just that one I that's not.
Yeah.
So the highlighted is just what you added to
Just
what
what
we
I
already
added
had?
Yeah.
Okay, yeah.
Thanks, yeah, I'm good with that. I'm okay. We have to vote on this?
I think you should. So I can send this to Slot.
Okay, I'd like to make a motion to add the words that has been presented to us under Chapter 285, Water, Article 3, Water Restrictions. Adding the word building commissioner
In 2 places.
in 2 places,
Okay.
as shown on the document.
I'll second it.
All in favor?
Aye.
Okay, good. Any other?
I didn't bring anything else because I think this is gonna be a long meeting, so.
That was a good meeting.
I have a question about the letter that went to the Board of Health
Oh, okay.
from Rod, right?
Yeah.
So,
I wrote it.
right, it was very good. So a resident contacted me, and because she contacted Mr. Russell, who told her that he was fine with things the way they were. So I didn't know what your take, Bob, or Rod, or Sean, whoever might know, how the Board of Health is gonna weigh in on this.
If he's fine with it, then he reports to the Board of Health. I don't know, was he fine with the letter I wrote, or he's fine with the system and the approval?
I mean, I don't know
Sounds like
how
he
he could be fine with the system, just from reading your letter. You
Right.
know what I mean? Like,
Right.
It was
So
pretty-
since that letter was written, we did get information from the manufacturer to allow Kate to evaluate the performance. That was one thing that we were waiting. They didn't give it to us, and then finally gave it to us. So from a nitrate perspective, she's okay with the performance based on the information they provide. The down gradient thing is up to them. It's in the Board of Health hands. As far as the groundwater discharge permit issue, or whether or not we should try to pursue that, I did speak with DEP. And DEP said that we gotta, if we push that issue, first of all, the chances, like Kate had presented, that the Title V is typically more conservative. The flows are more conservative. So that's typical. But from a PFAS scenario, they doubled the PFAS by proposing these 88 bedrooms or 56 or 57 unit development here, from what it was. So they have, I mean, we're concerned about the PFAS, and we really don't know what the levels and types of PFAS will actually end up dealing with, and what, you know, it's all gonna make its way to the wells. And the time of travel, I don't know if they mentioned it, but it's 2 to 3 years.
They didn't really say the time of travel.
No, it was
They
on,
had the
was it
1,000
chart.
days, 5,000 days
Yeah, it was
on
a
the
day,
chart,
yeah.
but
yeah, the time of travel is gonna vary because these are going east and then they're sweeping in around in towards Little's Creek, and then the water gets pulled
Right,
from the
yeah.
wells at that point. For them to really, I guess, provide us with more accurate, they really would have to do, you know, an intense groundwater model, where, you know, you're looking at a lot of different, you're looking at more test wells to be put in so that they can calibrate. And this approach, this desktop approach, is a reasonably accurate way and a conservative way. You're gonna get higher nitrates by the straight line to us to see if we really have a problem. So Anna gave us some indication of what the quickest travel time would be. It's gonna go sweeping around, but he modeled it straight on because he had gradients he could pull from the mapping that was
Right.
done by other reports. So he used that as a conservative approach. And it was somewhere around 2 to 3 years we would start, depending on what it was, not the concentration, whatever. And so you're looking, it wasn't 1 year. We were concerned that it was gonna be that quick, 1 year. But 2 to 3 years, we'll start to see elevated. It won't go up to the highest point. And keep in mind that 4 parts per trillion that he was talking about when he was using a threshold of 18, they used nanograms per liter, which was parts per trillion, 18 parts per trillion in the effluent. Keep in mind that it's in the plume and not necessarily, it doesn't take in the clean water. He says clean water, but it's, you know, the water that's coming in.
outside of that.
Outside, it could be, you know,
Water
it could
directly,
have some
right.
PFAS already in it, although, because we're not getting concentrations at the well, so these are our cleanest wells, and we're not getting it
Right.
there. So you could call it clean water,
Right.
but it does have low levels of nitrogen in it, from either wastewater or from the rainfall or whatever. It does have some low levels of nitrogen. So when you're talking nitrogen, you would add that to the concentration of that. That clean water would add to that concentration that was, you know, heading towards your well. It's a mixture though, so it's not like it's gonna be 4 parts per trillion. It's gonna be 4 parts per trillion in the plume that's coming in, but it's only hitting the well, and you're taking water from around the well itself. So it would be diluted to some extent. But
But I mean, that's in 3 years that, you know, we're not
3
gonna.
years after they start to generate.
Marshfield's not gonna cease to exist 4 years from now, like, we're gonna, hopefully.
Right.
But it's caught, once it hits that
It is
level,
gonna
it's gonna
increase.
They're
stand.
It's
concerned
just
about it,
gonna-
and they're also concerned, they used 18, and they're seeing from the other studies, even though we couldn't quote them, because we contacted them to see if we could quote them, and they said
The
we
one
can't
that
quote.
was in New Hampshire?
The ones that we could find, it's just no studies out there yet. I mean, it's just so new right now that there's not enough studies out there to really, you know, use the data. There were levels of, she said 300 of combined PFAS, and then the PFOA was somewhere in the 80s is what we were seeing from that particular development, and it was a similar type denitrification system that they were using to as a test case.
Yeah.
So that was similar data, and then there was also one down at Cape that they were using, and it was somewhere around 27 or something like that. So we don't really know what that PFAS is, but it was 4 times higher than what his threshold was to get 4 parts per trillion at the well. So 18, I think he's using, and then 4 parts per trillion is what the result is in the plume as it hits the well. So if it's 4 times more, then it would be 4 times more at the well. So even though it's grabbing clean water, it still could be four times higher, and it might exceed the 4 parts per trillion when you start to pump it out. Because of the higher concentrations coming out of the wastewater. You just don't really know enough yet. And that was one of the problems they had, because they were trying to find, studies that had that wastewater effluent PFAS number, and we just couldn't find it.
The same thing 12 years ago when dioxin 1,4 came out. Nobody knew how to treat it. You could detect it because it was every project that was made in the country, but there was no way to clean it up. There was no way to treat it. And all of a sudden that went away, and then PFAS came along. And it's got all
It
the
didn't go
same.
away, it just came
I haven't
back
back about
door.
1,4-dioxin in 12 years.
Yeah.
Now
Now it's
PFAS
PFAS.
is
What
here.
was it in? What was it?
In 1,4-dioxin?
Yes.
Everything that says PFAS, it just changed the name. All these systems and that's all we hear on every seminar we sit in or consultants. It's all about nitrates, but there's nothing out on the street that will treat the PFAS or the 1,4-dioxin. Nothing.
And carbon's not the answer.
Carbon is a short-time solution.
Absolutely.
After that gets filled up, it bounces off.
Well, then what do you do with the carbon after? Then it becomes a hazard
It's
waste.
like batteries in electric cars. What do you do with them afterwards?
It's a never-ending battle.
What's Duxbury doing with their
Well, Duxbury's
situation?
spending, what, $18 million
But
on
how
their
are
water
they,
treatment system?
but what are they using?
You just
Using
deal with
carbon.
They're
as far as I
using-
know.
Never ending,
I said that.
yeah.
They probably have to do tests, they have to find out what they're treating it for, but the last time I talked with Sean, because he kind of outlined what he was doing over there, Sean Neely,
Oh,
who
yeah.
does our material testing from Weston and Sampson. He said that they were studying, what to do. Where is it coming from? What's the major source that they hadn't pinpointed?
Oh, really? They don't know?
Well, they might have, by now, they probably have, but, a month and a half, 2 months ago, he didn't tell me that he knew, but he probably kind of knew where it was coming from, but they were doing,
The woman that was sitting here, Kate Russo, is probably one of the best in the business. She
They're
knows
both good, they're all good.
exactly what's going on, and I stay in contact. I've known her for quite a few years, and if I have any questions, I always bounce it off of her, because if she doesn't know, then nobody really knows.
Yeah.
But we're in good hands with them, I feel.
DEP doesn't know what they're gonna do about the wastewater side, they don't know what to do. They haven't, they're not telling anybody, and
Trying to come up with new regs.
As far as like requirements, how do we make requirements when the laws are gonna change? Like, they just came out with these guidelines and laws, like in April, right? So that's gonna change, it's gonna
It's gonna
evolve.
take a year,
And,
plus.
and then they're gonna be adding, well, like I asked about the wastewater thing, like, how do we cover that with this project when it hasn't happened yet? You know
So
what I
you
mean, like the laws?
adapt to the change. We gotta have our stipulations in order, and when things start changing down the road, we have to add to that.
Okay, so there has to be some kind of thing in the requirements that we can evolve the requirements with whatever is happening
Subject to
in the.
changes.
We can put a well on our property, which is
Well, what
east,
we're gonna do, yeah.
east of their site,
Mhm.
and we can test for PFAS. And then we'll see the PFAS coming across from the east. It's gonna go that way, at least that's what everybody says it's going. And even their consultant way back when we were doing the soccer field said it was going in that direction. That we'll pick it up and we'll see what the PFAS levels are. They're not gonna sample PFAS on their site because it's a regulated contaminant right now. And if all of a sudden they start reporting levels below the MCL, they got problems.
That's why we wanna put it right on the edge of the
21E
property.
issues, right?
Become a 21E site.
That woman, we have the right to go and test for anything we want.
So are we doing that, like, now?
We're gonna, no, it's in the next phase.
Okay, oh, that's good.
We can try and buy the property.
So, I know,
And
so
storage.
they can't, I have one more question. So they can't use the credit land because it's not where they thought it was. But that doesn't matter because, this is what I got from the thing, because the nitrogen's still gonna be below what it needs to be even without that. Was that accurate? Is that accurate what I just said? Because that's what it seemed like she said.
It sounded like what she said, but I'm not sure if she made her point clear. I mean, they are still using the credit land in their calculations.
Yeah, but they can't, they're not. I mean, they showed that it's not even going that way, so how can
Did she
they?
say we should buy it?
I don't know what she said.
That was this afternoon, we talked to them.
Oh,
We should buy the credit land.
I wasn't sure about the credit land, yeah, whether or not the town should own.
Oh, you're
take
sleeping
control.
then, that's right, I forgot.
I wasn't sure
Wait,
whether or
didn't
not
the
the
town
town
do
should
that?
own the credit land, even though they're taking credit, should we own it just to possess it, just to, for future,
But you guys had it right.
Oh,
Buy the bond.
so the town doesn't own it, but with an easement, is that what it is for it? I thought that we had that land.
we don't, we got an easement for the stormwater.
Oh, okay.
We have that easement for that, but the future, we have like, I think first right refusal for the 5-acre parcel.
Oh.
I'm pretty sure that's what was in the, an agreement. I'm not 100% sure, but I think that's what it was in there. So, I mean, we could buy that, or they were gonna actually give it to us. I'm not sure what.
Oh, I think that's what it was, because Greg wanted to put it in the, what's that called, 3 and 4 initials land, I can't remember.
Yeah, he wanted to
It's the-
include that for the count, for the 40B number of units, or the number of acres that the town.
The acres, yeah, I can't remember what the acronym is
I
that
can't
he
either, but
used.
he wanted, and I think they would have to own it in order for that. No, we could,
We would have to own it,
we would have to own it?
yeah.
Okay, well then, if that's the case, then we probably would want to own it, and so maybe that.
I think that was part of the deal,
Clarify
that they
with
would give
Greg.
that to us, and then it would be able to be used for that. Oh, I can think of is GATRA, and that's wrong, because that's funds. But I think it starts with a G. Huh?
MBTA.
Yeah, no, I'm talking about a land use, no, never mind. I'm
Well, if you think this,
rambling
this parcel's a problem,
now.
if that MBTA piece went through,
Good.
that's all our Furnace Brook water supply recharge zone. And then put mega apartments there. I mean, without putting a sewer down 139, we're not gonna have any drinking water at all.
Another 500 units, they said.
500 units. What a nightmare. Sean, anything else?
No, sir.
So what about?
Any other, any closing remarks?
So, next meeting is.
Thank you, everybody.
June 9th, June 3rd.
Okay,
I make a motion to adjourn.
second.
All in favor?
Aye.
Thank you all.
Thanks, Larry.
Thank you, Rod, for all the work.